Bismillahirrahmanirrahim. Assalamu alaikum class. Introductory lecture, video lecture for the fourth lecture of your first semester of the course Operation Research. And topic of the lecture will be the simplex method. We will revise it, and then the new topic will be two-phase method and M method. Actually, most real-world linear programming problems have more than two variables and thus are too complex for graphical solution. So a procedure called the simplex method may be used to find the optimal solution to multivariate problems. The simplex method is actually an algorithm with which we examine corner points in a method of fashion until we arrive at the best solution. Highest profit may be, or the lowest cost may be, and some computer programs and spreadsheets are available to handle the simplex calculation for you. But we need to know what is involved behind the scenes in order to best understand their valuable outputs. So in practice, most problems contain more than two variables, and for the linear programming problems that have more than two variables, simplex method is the best method. We have to follow some rules and algorithm to find out the simplex method optimization solution. So simplex process phases are problem formulation. First we formulate the problem, then finding the solution, and then finding the implementation of the solution. Simplex method steps are, first of all, we find the problem, then we find the facts, then we define the problem, then we define the idea that can solve the problem. We evaluate the idea and we select the best idea that can give us the optimal solution. Then we perform the action for planning. Then we accept that we want to gain, and in the last we take the decision and we implement it. Linear programming with the simplex method, learning with this came to know about simplex method, or knowing about the technique how to solve the linear programming problems with the simplex method. You will able to solve systems of inequalities also. You will be able to solve linear programming problems by graphing. You will be able to solve standard maximum problems, and you can understand and use duality within the simplex method and can solve non-standard problems using the simplex method also. Simplex method have the steps or algorithms as shown on the slide also, but in the depth, if I want to see or can explain that, first of all, we add some slack variables to change the constraint into equations, and write all variables to left of the equal sign and constant to the right sign. This is called the standard form. Then in the next step, we write the objective function with all non-zero terms to the left of the equal sign and 0 to the right. The variable to be maximized must be positive. Then we set up the initial simplex W by creating an augmented matrix from the equations, placing the equation for the objective function last. That is, we determine the slack variables, we put all the decision variables is equal to 0 and can find out the value of the slack variable. And the other is that we define our initial simplex table and create the augmented matrix by putting the values into it. Then can determine a pivot element and use matrix row operation to convert the column containing the pivot element into a unit column, and if negative elements still exist in the bottom row, we will repeat the step. And when the final matrix has been obtained with no negative value, then the final basic solution is there. This will give the maximum value for the objective function, and the values of the variables will be the maximum. So if I explain them according to the rule, then what we have to do in the simplex method is, first of all, we convert the given general linear programming problem into standard linear programming problem form. And in the second step, we will write the values of initial basic feasible variables. In the third step, we write the standard form linear programming problem into matrix form. In the fourth step, we construct the initial simplex table. In the fifth step, we calculate the value of Zj minus Zj and check the feasible basic solution for optimality. We made a table, and in table topmost row is of Cj. Cj is the cost of the objective function. Second row, we will give the attributes of the columns, and they are CB, the basic variables cost. Then B for the basic variables, that are slack variables, X1, S2, S3, X4, how many that we will introduce, and XB will the cost of the constraints. In X1, we will write down the coefficients of the X1 in both the 3 or 4 or 5, how many equations are there. X2, we will note the coefficients of X2 variable, and S3. In X3, we will write down the coefficient of the X3. Then we have slack variables, and we will write down their cost. We will also add their cost into the maximum function as also whether it is of positive or negative. And in the last column, we find out the Zj minus Cj by the formula CB Xj minus Cj, and it must be greater than or equal to 0. Then in the sixth step, we calculate the minimum ratio, and minimum ratio is equal to XB over CK. Then CK is the key column, and we will also find out the key row and key column, and the intersection point of key row and key column is the key element. Key column show us the incoming vector, and key row will give us the outgoing variable. Then we will construct the new simplex table by entering incoming variable, and we will repeat this process in the next for the second iteration and also for the third iteration, and we will repeat it until we get the all the positive values in Zj minus Cj. And we will then test the iteration and divide the key row with the element. This is on the screen here in the slide. I have shown an example. We have the objective function of maximization, and we have to maximize 2x1 plus 10x2 plus 15x3 with the given constraint are 3x1, 2x2 plus 3x3 less than or equal to 55, and then second constraint less than or equal to 26, and then the constraint less than or equal to 30, and then the constraint less than or equal to 57. X1, X2, X3 should be positive. Here is the feasible solution that we find out with the help of the graph. But now we will try to find out its solution with the help of the simplex method. And simplex method, this we also have the simplex method, and that has the 3 decision variables. One other thing you have to note down, that if your objective function is maximization, then keep it as it. And if your objective function is of minimization, then what you have to do, you have to multiply your given whole maximization or minimization equation with the negative sign, and then it will become the maximized function. Minus negative, minimum will be changed into the minus negative maximum, minus 2x1 plus, this is 3x2 of minus. So when we multiply it with minus, it becomes plus. So plus 3x2, and x3 is plus. So we will multiply it with minus. So it becomes 3 minus x3. So keep in your mind, if it is objective function is maximization, you have to keep it as it is. And if it is of minus, it is of minimization, yeah, then you have to multiply all the equation with the minus sign. This I already explained, that you have to, this is the algorithm for the simplex method for solving the linear programming problem. So you have to add the slack variables. You have to add the surplus variables. If the amount of resources by which the left-hand side of the equation exceeds the minimum limit, you have to add the artificial variables. If artificial variables are temporary slack variables, which are used for purposes of calculation and are removed later. There is a table which can show you the constraint type less than or equal to add slack variable. If it is greater than or equal to, subtract surplus variable and add artificial variable, such like minus s plus a. And it is, if it is of equal to type, then add artificial variable plus a. So procedure for the simplex method is, as we have discussed earlier, formulate the linear programming problem, then introduce the slack variables, then find the initial basic solution, then establish a simplex table, take the most negative coefficient of the objective function zg to identify the key column, and then find the ratio between the solution value and the coefficient of the key. And then in step 7, take the minimum positive value available in the minimum ratio. In step 8, the intersection element of the key column and key row is the pivotal element. And then in step 3, construct the next iteration and repeat it until you get all the positive answers of Zj. So here is an example, and we have already solved it in the class, and for your practice, it is given to you. You can see this is your standard form. You have changed your given linear programming problem into the standard form. Standard form means that you have changed the inequalities to the equalities and added the slack variables S3 and S4. And in the maximization function, you have shown their cost, and their cost is 0. So from these two equations and from the maximization objective function, we will made our simplex table. We have first column is of basic cost of basic variables. Second column is of basic variables. Third column is of the XB of the cost. And then in above row, we will show the cost of the objective function, and last row will be the Zj minus Cj. And then in the matrix, we will write down the values of the x1 variable, x2 variable, s3 slack variable, and s4 slack variable. We also find out the minimum ratio. Minimum ratio will be equal to xb divided by ck. So it is solved and also explained. You can see it and can improve your practice and technique of solving the simplex method linear programming problems. Here are two types of questions are given for the large data and for the small data. Now come to the point and today's topic, that two-phase method. What is two-phase method? For greater than or equal to constraint, the slack variable has a negative coefficient. Equality constraint do not have slack variables. If either of the constraint is part of the model, there is no convenient IBFS, and then hence two-phase method is used. In phase method, we find an IBFS to the original problem. For this, all artificial variables are to be derived to 0. To do this, an artificial objective function Z star is created, which is the sum of the all artificial variables. And similarly, the second step, if the minimum value of Z star is 0 and no artificial variable appears in the basic at the positive level, then the given problem has no feasible solution and procedure terminates. So this is also given the different conditions of the feasible solution. Phase 2, when phase 1 result in B or C, will go on for phase 2 to find optimum solution to the given linear programming problem. The basic feasible solution found at the end of phase 1 now used as a starting solution for the original linear programming problem. An example is given to you. Here is the objective function and the constraints are given to you. What we have done, we have created a Z star, a maximization function with the artificial variables, and then we inverted the inequalities into the equality form. We created a table and we find out the entering variable and outgoing vector. And similarly, we again find out in second iteration and third iteration our incoming vector and outgoing variables. Then we consider the final simplex table of the phase 1. Consider the actual cost associated with the original variables. Delete the artificial variables, A1 column from the table as it is eliminated in phase 2. So maximization of 5x1 minus 4x plus 3x3 plus 0s1 plus 0s2 will be 5x1 plus 4x minus 3x3 minus os1 minus os2 is equal to 0. Then we create the table and we try to find out the equation. This is the second example and we will inshallah see and solve it in the class. Then we have another example. Also, there are some solved examples on the book of operation research by Hamdi H. Taha, which I have already given you in the assignment. And so different examples are given of the simplex method and the phase 2 method and also the M method. M method is a method of solving linear programming problems. It is one of the oldest linear programming technique. Big M refers to a large number associated with the artificial variables, and the big M method introduces surplus and artificial variables to convert all inequalities into standard form. Algorithm for the artificial variable in the model is that add only to the greater than or equal to type or the equality constraint. A value m is assigned to each artificial variable. The transformed problem is then solved using simplex, eliminating the artificial variables. These are the different points that no artificial variable appears in the basic and the optimality condition are satisfied. Then for at least one artificial variable is the basic at 0 level, and then bases at the positive levels are given. And other example is given to you of M method and their solution. So analysis of big M method is with the help of solving the positive M method for very large data is optimal is finite and optimal is unbounded. If optimal is finite, then S is equal to 0 or optimal solution of P is found, and S is not is equal to 0, P has no feasible solution, S is equal to 0, optimal solution of P is unbounded, and S is equal to 0, P is infeasible. And this is all, drawback is given, conclusion is given, and this is all for the lecture on the 7th November. Inshallah, in the class, we will try to solve these examples and find the solution and the method and the techniques of simplex method, two-phase method, and M method. Thank you, students, and Allah Hafiz. May God bless you all. Allah Hafiz.